Yeah, so a box with no lid has a volume of 33 cubic inches. The base is square with a side length of x. So first of all, let's draw a net of what's going on there. So we have the square base, side lengths of x, all the way around, of course. And then the height of the box, so if we drew this in profile, that would be the square base, x by x, and then its height would be something like that, right? And so that would be h. If we draw the net out, then it would look something like this in every direction. Now, that should actually be like the same height in every direction, so just imagine all of these lengths are h. But it doesn't really end up mattering. What we want to compute is the cost as a function of x. So that's part A. Paint for the sides of the box. Why would the paint be different costs for the different parts? That makes no sense. Oh well. $10 per square inch along the base, and no, I'm sorry. $10 per square inch on the sides of the box. So in here, this is $10 per square inch, but then the base itself is only $3 per square inch. Again, why would the paint cost a different amount? Because we have a math problem to write. What would I do? Well, first of all, I want to relate h to x, because then I can write an equation for the total cost using the surface area of the box, because obviously the paint is something that we're painting on the surfaces. It doesn't directly have to do with volume. But we are given this volume up here of 33 cubic inches. So what I would say is, all right, so our volume is clearly x times h, or x squared times h. But again, we know the volume is 33, so we could say divide by x squared, divide by x squared. H is the same thing as 33 divided by x squared. So that ends up helping us, because now we can figure out the surface area of the box. And again, I'm going to do surface area in two parts. One having to do with the $10 per square inch area, and then the other having to do with the $3 per square inch area. So the $10 per square inch area, we have 4 of these rectangles, and each one of them has an area of h by x. But again, h we know is 33 over x squared, and x itself is just x. And so those 4 rectangles end up, once we simplify here, with 132 over x as the total area there. And then, of course, we want to multiply by 10. So if we're keeping track of our cost function, we've got 132 over x times 10. 132 times 10 is 1320. And so that should be the cost for all 4 of those purplish rectangles there, the ones that are originally h by x. But again, we have now stated them in terms of x. Of course, we also want to keep in mind the base, which has an area of x squared square inches, x times x, right? And then we want to multiply that by $3 per square inch. So that should just end up being 3x squared, I believe. Yeah, so I think that should give us our cost function in terms of x, the length of the side of the base. From there, what is the minimum cost to paint the box? Well, I presume we can graph this in our graphing calculator. So I'm going to say y equals 1320 divided by x plus 3x squared. And we're going to have to zoom out. This is going to be an odd-looking function. We don't want to let x be negative, so the fact that it kind of goes down forever on this left side doesn't really matter to us. And it looks like there's some kind of asymptote happening at x equals 0, which makes sense, because obviously we can't plug in 0 to this function and get a value back. But then over here in quadrant 1, where I actually have values that make sense, it looks like when we let the base of the box be a little bit above 6 inches, 6.037, we get a minimized cost of $327 $300.99. So I would say, okay, what is the minimum cost? This is an expensive box. $329, wait, was it 29 or 28? $327.99. What is the value of h that will produce the minimum cost? That's interesting. So we've switched between variables h and x. But again, we have an equation that relates h to x. So all we have to do now is plug in 33 divided by that value, 6.037 squared. And so let's pull up our calculator. 33 divided by 6.037 squared. So this is an awfully shallow box. The height right now is only 0.905. But that actually makes sense, of course, because again, these sides here, the purple sides, were so much more expensive compared to the base that if we hold that volume constant at 33, to minimize our cost, we want the base to be as large as possible compared to the sides of the box. We want those to be as small as possible. So it makes sense that the height would be pretty small here. What is the area of one of the sides of the box that will produce the minimum cost? I presume that means the purple areas, the sides of the box. And again, that's going to be x by h. So that's just going to be that same 6.037 from our graphing calculator minimum times the height, which we just found was the 0.9054 blah, blah, blah. And so it looks like that is 5.466. So that would be in square inches. 5.466 square inches. So that's how I would walk through number 1.